A law of conservation is often introduced in elementary school. Lessons teach how it's not possible to subtract more than an ounce of water from a glass after adding it, or subtract more than an amp hour after adding it to a battery. Mass, charge, energy, they're the most well-known quantities governed by a conservation law. And now, we introduce a new quantity, earning citizenship in the land of physics: information. Applying a conservation law to information, or data, is not only possible, it solves some of the world's most important problems. Let's use JavaScript. An object is a type of data that stores keys paired with values. To express a conserved quantity through this object, we need only to declare an origin, a destination, and a quantity. To give these keys and values context, we'll store this object in a variable named transaction. What information is required by a transaction? Seller, buyer, price. Mary is the seller. John is the buyer. And the price is 5. When the seller and buyer approve the information in this transaction, the transaction records a change in ownership of value between them. Mary's account increases by 5. John's account simultaneously decreases by 5. Value is neither created or destroyed, only transported. The novelty of treating usernames as positional coordinates enables applying a conservation law to trade. Just as current flows in the opposite direction from electrons in a universe conserving charge, goods and services now flow in the opposite direction of value through data conserving information, or modeling a currency as a current. So what very important problems does this new application solve? There is an institution that is allowed to violate this fundamental physical law, or at least try. When you deposit money in a bank, and the bank lends your money, the bank receives government privilege to issue you a statement telling you your money is still there. How would you like to borrow money, spend it, and then receive the privilege of telling your lender you still have the money? Before accepting, understand that what economists call the money multiplier effect is, to a physicist, nothing more than double counting money's ownership. And it is not without side effects. You work for 2 weeks, deposit your earnings in the bank, and the bank lends your money to a borrower. The bank is then allowed to declare the note it purchased from the borrower as equal in value to the work you performed over the past 2 weeks. When you're required to work for money, banks receive the privilege of merely expecting it. And expected money is not equal in physical value to earned money. If the loan fails, the increase in money, which now includes the note purchased by the bank, becomes greater than what was produced. And this is monetary inflation. And when the bank defaults, other banks and businesses expecting money from each other default. That is, we experience a cascading collapse from government systematized risk. All these issues and more are solved by applying a conservation law to information. If you decide to lend your money to a finance company, a conservation of value will force the finance company to tell you the money was lent. And if the finance company defaults, no other accounts are affected. Modeling the economy according to the same law the universe models us, eliminates the instability produced from attempting to violate it. This is not advocating another cryptocurrency or blockchain. Instead, beginning with the simple structuring of data, according to physical law, is far more effective than jumping ahead to the complicated schemes and technologies used to distribute, replicate, and encrypt data. You may assist the movement to apply an inviolable physical law to an economy by registering for and sharing the White House petition on systemaccounting.org, studying its materials, and contributing development resources on GitHub and PayPal.